Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to listen to it on demand. Following today's presentation, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question, don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. We'll take a few minutes near the end of the presentation and go through those questions. Okay, with that, we'll go ahead and kick off today's webinar, which is the Open Source Security at Scale, the DevOps Challenge. Our speaker today is Shiri Ivtsan, who is Product Manager at WhiteSource. Hi, Shiri, how are you?
Hi, great. How are you?
I'm doing great, thanks. Thanks for joining me today. I'm going to go ahead and put myself on mute and let you get right into your presentation.
Thank you. So hi, everyone. Thanks again for joining this webinar. So today we're going to discuss a very big and challenging issue, which is open source security at scale, and specifically what are the DevOps challenges with open source security. So nice to meet you. My name is Shiri Ivtsan. I'm a product manager at WhiteSource. So continuous delivery is sort of a word that we hear a lot these days, specifically as DevOps. Everyone wants to be agile and everyone wants to ship their software as much as they can, as fast as they can. And this is one of the biggest challenges. So when it comes to continuous delivery, we must not forget the security part, which is a challenging one. So it's security in general and also open source security. So if we drill down and go to the open source world, as we want to ship our software faster, open source, I think, is one of the things that helps the most, because you can actually share code, you can get other people's code without even writing it. So it's a very big advantage. However, there is a risk with it. So regarding open source, we have more than 96% of the developers that actually rely on open source components. So this is according to a survey that we've had in WhiteSource last year. So you can see that very small percentage of the developers don't use open source at all, maybe in traditional companies like banks and other companies, but most of them actually use open source all the time. So even in big companies today, we rely on open source very extensively. Now, regarding security in open source, so as open source in the last few years became more and more famous and more people are using it, we can actually see that the hackers are also viewing it this way. And what they actually see is that they can add all kinds of vulnerabilities to the open source code. And then it's already a matter of who is actually controlling the open source. So we usually have pull requests and we have contributors and maintainers inside open source. And if I'm a hacker and I want to just set a vulnerability in one of the open source codes, all I have to do is add the code, open a pull request, and hope that someone will actually approve it. And in some cases, of course, open source vulnerabilities actually slip into even very big repositories. So this is one of the challenges. In terms of some basic statistics based on a survey that we've had, so open source vulnerabilities are on the rise. We're actually seeing more and more open source vulnerabilities as we go along this year with years. So as we said, as open source becomes more and more rising and becomes more and more famous and more people are using it, the open source vulnerabilities are rising as well. So you can see that on 2017, we had more than 3,000 open source vulnerabilities. And in 2018, and this survey was actually done in the middle of 2018, so we see also these are on the rise. And in average, more than 50% rise year by year. The second thing that we see as an open source challenge is that developers and developer manager say they have a lot of challenges when dealing with open source. So it's not only security. We have other challenging things, like, for example, the functionality of the open source. So you have to make sure that the open source component that you choose is the right one in terms of the functionality. There is also, of course, the distribution and licensing challenge. So you have to make sure that you can actually distribute this open source. But when we went to developers and to developer leads and actually asked them what is the most challenging part, it was definitely security. And you can understand why. And the last thing that we've actually learned is that companies don't really prioritize their fixes efficiently. So what we can actually see is that not all, but most of the most of the businesses don't actually decide and prioritize the open source fixes based on real business impact. So we got all kinds of questions when we actually asked them, how do you prioritize the fixes? So one of them was availability of the suggested fix, which of course doesn't have anything to do with real business impact of that vulnerability. Number of software libraries in containing the vulnerability, which might make sense. The creation date of the vulnerability alert, which also doesn't really make sense in terms of real business impact. So we see also a challenge in prioritizing. So we thought we would actually show some recent vulnerabilities that were found, and we categorize them into three main parts. So the first one is integrity, and we see a lot of these. We've actually saw these a lot lately. So integrity comes to, let's say, someone actually hacks into my cluster with an open source vulnerability and uses remote code execution. So they can actually control my cluster now, and they can execute any code that they want on my machine. We will soon see a demo of that, actually. The next one is availability. So we see that a lot with Bitcoin mining and mining other coins. So we actually there was a big exploit in Jenkins servers, and hackers were actually able to make more than $3 million by just mining Bitcoin or Monero, so the cryptocurrency. And this actually is very dangerous because hackers can use your actual performance resources, so CPU and memory, for their usage. And the last one is probably the most dangerous one, which is the security protection part. So we've recently had a few of these. I think yesterday or the day before that, there was a vulnerability in runc, which is the underlying runtime of Docker and of Kubernetes. And this is another one from earlier this year on December last year, where Kubernetes actually disclosed a critical privilege escalation flow. So that means that me as just a user in the cluster can actually get a lot of privilege. So that's very dangerous as well, and this is the most dangerous actually. So without further ado, let's go into the demo. So in terms of today's demo, let's just discuss a little bit about the infrastructure and about the what we have here. So what I'm going to show you basically is how easy it is to actually deploy a vulnerability into your own cluster. And cluster is just a matter of, infrastructure here. It can also be an application or any virtual machine. So what I actually have here is a Docker file, and this Docker file is based on Alpine. It's a very general one, nothing special about it. So I'm installing Struts, and then later on I install Tomcat, and I install my super cool app, as you can see here, just a WAR file. Now, what do I have inside this WAR file? So I've actually deployed this to Kubernetes. So now let's see what I have inside Kubernetes. So I'm just gonna kubectl get pods. And meanwhile, I can say that, of course, Kubernetes is just an example. You can deploy vulnerabilities very easily as you deploy code on any other machine. So here you can actually see the kube struts. So this is what I've actually deployed. Okay. Now let's look at my applications. So this is my application. I've actually deployed a very general application, so you can see it's sort of an order application, so you can see the ID, you can see the client, the amount. For example, I can edit an order, I can delete it. So just a general application, right? Nothing very special about it. But what is special is that my version of Strut that you saw here actually has a vulnerability. Now, another thing that I wanted to show is the actual YAML file that I deployed to Kubernetes. So there are two things that are not very recommended in terms of security here. The first one is the security context that actually says privilege true. This is not a best practice in terms of Kubernetes. And the other one is mounting the Docker sock as a volume. So that's also not recommended. And this what actually will make sure also in this demo that my vulnerability will be seen. So as I went to this kubectl get pods, what I also have here is another server, just a general Ubuntu server, and I'm going to use this in order to actually deploy my vulnerability or sort of hack the cluster. So what I'm going to do is a very simple command. It's actually a simple Python command, Python code with the vulnerable element. So you can see that I'm actually going to my super cool app, and I'm trying to run a cmd command. And what it actually does, just as an example, it tries to create a file, just a simple file with an exploit. So before I'll create the file, let's see that I don't have it yet. So I'm gonna very quickly go inside the Kubernetes cluster and see what I have inside. So I'm looking at the general cluster, and I'm looking at what I have here. There is no Shiri exploit, as you can see. And now what I'm basically going to do is run this code. And this code actually says what's the URL, what's the command, the request sent, and I've also written in my code that if the host is vulnerable, the command will be executed in the background. So that actually means that now if the host is actually vulnerable, the command will appear here, and my file Shiri exploit will actually appear here. Okay, so what I'm gonna do, I'm gonna cd and just ls, and you can see the new file Shiri exploit has added. So adding a file is just an example. Of course, that once I have from within my remote machine, I have access to this cluster now. So you can see that this is very, very, very dangerous. And this can happen on each one of the clusters that you guys probably own. So just 2 days ago, as I mentioned, a new vulnerability in Rancy was detected, another privilege escalation one. And Rancy is actually the underlying of Docker, of Kubernetes. So it's very important to make sure that you patch this vulnerability, just as an example. So now let's continue with the presentation. And what I'm actually saying, and what we are actually saying, is that it's really important to make sure that you secure your entire software lifecycle. That's how you can avoid such vulnerabilities when a hacker just goes into your cluster and does whatever they want. So the key word here is really to scan. So when I say scan, I actually mean go and look for existing vulnerabilities online. So there are a lot of security databases, the NVD, for example, and there are others, and a lot of issue trackers as well. So a lot of security vulnerabilities are being published every day, usually in GitHub or in the NVD. So what scanning actually means is scan your code and check for existing known open source vulnerabilities. The way it usually works is you have WhiteSource, but you also have a lot of free tools out there that scan your code. So how or where is it possible to scan the code? It's actually possible quite everywhere in the pipeline. And as the main idea of shifting left, it's also relevant here because as we shift left with deployment, as we shift left with remediation, we're actually able to deliver our software in a more secure way and in the easiest way. So we have selected these stages in the pipelines. We've actually divided the software lifecycle pipeline into coding, the part when you actually choose the component and write your code. Then you build your actual software, you package it. So for example, if it's a container, you can put it in an image registry and then you can deploy it. So if we look at the code part, I think that the most important part is to choose the right component. So there are a lot of open source components, of course, that do the same thing, more or less. So they have the same functionality, but one of them has less vulnerabilities than other. So it's really important to know which component to choose. And again, this is about scanning the code. Another thing that you can do, so if you use GitHub, Bitbucket, GitLab, or any other registry, you can actually automatically open pull requests for patches. So patches are being published almost every day for known vulnerabilities. And as a matter of fact, it's also best to have the latest version as you can, because this means less vulnerabilities. Usually, even if something was patched, a vulnerability was fixed in a newer version, hacker will still try to execute the vulnerabilities because a lot of developers and a lot of companies don't actually have the latest version of the code. So it's always important to open pull requests for patches. If you can do it automatically, that's even better. Another important thing to do is to restrict merges if vulnerabilities exist. So again, there are a lot of open source components that can actually do that today. So what we actually say is, for example, if I'm a developer and I currently write a code on GitHub and for some reason there is a vulnerability in one of the dependencies, the tool will automatically restrict the merge if it detects any vulnerabilities, which makes sure that no vulnerabilities will go actually to the next step. And the next step is build. So by build, I actually mean you go to Jenkins, TeamCity, Circle CI, Travis CI, and you actually build your software. Building is the time that makes a lot of sense to actually scan for vulnerabilities. Because usually during build, whether if it's nightly build or you build every week, you usually have tests. So these are functionality tests. And of course, if one of them will fail, the entire build will fail, because this means that some of the functionality of your application is not working well. And the same exact thing goes for vulnerabilities. If I scan on build and I test and I make sure that I have no vulnerabilities in the build stage, exactly as the functionality part. So this means that on any low, medium, or high vulnerability, I will automatically fail the build, making sure that there is nothing that slips out and somehow goes to production. So this is the part of failing build based on any policies. So it can be high severity vulnerabilities, only fail your build, but it can also be any kind of severity will fail the build. The next part is package. So this is more relevant for images or containers where we actually package the file and we save it in an image registry. And also in the image registry level, it's very relevant to scan also here. It's very important because sometimes that's the stage that you merge all the components. So let's say you develop something, but you also have some third-party integration that you see only in the package part. It will make a lot of sense to scan also in this image registry, as that's where you can detect if there's any dependency in your third party that's vulnerable. So that's another important step. And the last part is actually the deploy part. So you scan upon deployment to production platform. And that means that whether if you're deploying to a virtual machine or you're deploying to a container image, or it can also be container orchestration platform like Kubernetes or Rancher or anything like that, it's really important to also test for vulnerabilities at the deploy stage. And there are various ways you can do that. So you can also use some free tool that does it before you deploy to production, or for example, you can use something inside your deployment platform. So for example, you can deploy a pod within Kubernetes that keeps on scanning for vulnerabilities and makes sure that there are no vulnerabilities once you deploy to production. And of course, it's also very important to monitor running applications inside production for newly published vulnerabilities. And that's also why it's so important to keep and make sure that you test vulnerabilities on any point in the pipeline, because there are a lot of new vulnerabilities that are actually published every day, and this becomes more and more serious and challenging, because each day we find new vulnerabilities. So even if you've gone through this process and you've tested in the research part where you chose the component, and then you tested again inside the code, inside GitHub, and then you tested in the build part and in the package part, and even in the deploy part, one day later you can see that there is new vulnerability that's actually affecting your entire system. And that's very dangerous. That's why we need to be aware of it and keep on testing it also in production. So what you can actually do is make sure that you have something like a daily or even hourly test of vulnerabilities, usually during nighttime, for example, so that it doesn't really affect the performance of your system. And that's what we can do to make sure that there are no vulnerabilities. Actually, the production part, of course, as we try to shift left, we'll also make sure to notice the production part, because this is the most relevant and the most dangerous one. After you've deployed a vulnerability to production, there is really no going back. So that's why it's so challenging. So the key takeaways from here are actually, the first one is to know your code. And know your code actually means that you know all the components that you're using, that you scan and monitor it frequently. So this means that, for example, there are no open source components that you haven't done research for and that you're not familiar with. The second is to monitor it. So as we discussed, whether if it's on nightly builds or inside production or in your image registry, it's really important to frequently make sure that you monitor it and check for new vulnerabilities. And the last part, I think, is the most relevant for DevOps, is in order to make it simple and faster. Of course, we don't think that anyone will do this process manually, as it's almost not possible. We need to automate this. So this actually means that we automate the scanning, for example, as part of the build. Then we need to somehow automate the prioritization based on business value, of course. And the last thing is to automate your remediation. So automate your remediation is just as we discussed, to open new pull requests for new versions of the software. And I think this is really the key value for scanning and making sure that you're secure all the way from the very early stages of development all the way to the production part. So I think that's basically it. And it would be really great if you guys had any questions. I think we already have some.
Yeah, we've gotten a couple in so far. So why don't we go ahead and just jump right on in. But before we do, just want to remind the audience that if you have a question for Shiri, just use your GoToWebinar control panel and submit your question in the question tab, and we'll get to as many as we can. Here's the first one, Shiri. Which coding languages have the most vulnerabilities based on your research?
So actually, we've done a research for that this year, and we've tested the 7 most popular coding languages. So within these, we had Ruby and Python and Go and C and also C++. So 2 things that I can say. First of all, there is no really such a thing as, the most vulnerable language, because the language with the most vulnerabilities, according to our research, was actually C. But C is also a very extensive language. It's not a new one, so that could be a reason why it has so many vulnerabilities. And even if it has a lot of vulnerabilities, it also means that people are watching them and being protected from them, and that we have a lot of fixes going on. Another thing that I can say is that the language that was the most secure was actually Ruby. And that also makes sense. It's quite a new one. It's not a very complex one. So this can actually explain why this is the most secure languages.
All right.
Yeah.
Okay. All right, great. Next question. Let's see. How is container scanning different than regular code scanning?
Okay, so we sort of touched on that a little bit. Containers are very, very famous these days, and more and more people are using them. They're easy, they're very fast to implement, and also fast to ship. But maybe the not so good thing about containers is that they are new. And as they are new, we have sort of lack of visibility. Because there are not a lot of tools that give DevOps or developers see the actual vulnerabilities. Another challenge in actually when we speak about container security is also that there is a larger attack surface. So as we know with regular VMs, if we protect the process, everything is protected. And this is not the case with containers. And also in terms of open source, we recently see a lot of open source vulnerabilities containing the privilege escalation and the runtime of the containers. So that's also a very big challenge, and it's very different from regular VMs. What we do have to remember, though, is that protecting VMs is quite similar to protecting virtual machines, because a process is still a process. So all the things that we know from protecting VMs or protecting regular applications are still relevant. This actually means that if you don't run as root in regular applications, you also don't run as root as a container. And the way to do this is also, another way to do this is also sign the images. And as we just said, also scan the images for vulnerabilities, which is the same thing as regular code.
All right, great. Let's see. Next question. Okay, hello. We are running on GKE. For one side, we are using Sonar for code analysis. Are there any recommended tools for security scans? And then he adds, our stack is basically Go, JS, and PHP.
Okay, so yeah, so in terms of GKE, and not only in GKE, but in all of the managed services, you have sort of very good tools by the managed service that gives you the security part. So it's in GKE, in their image registry, and also in AWS. So ECR has and not more protection options. And what I recommend in terms of tools, so again, searching for good tools to scan, free tools to scan your infrastructure, or tools to scan images, or tools to scan codes. So there are a lot of open source solutions. I'm sure that a quick Google search will find them, and there are also solutions, paid solutions, for example, WhiteSource. So specifically for GKE, if you're using the Kubernetes engine, as we discussed, you can deploy something inside the cluster that will actually monitor for vulnerabilities. So this means that you don't have to do it manually, of course. The cluster will automatically initiate scans for security vulnerabilities, and this is one service that's offered by WhiteSource, for example.
All right, great. We've gotten some great questions in, but there's plenty of time. If you have a question for Shiri, please use your GoToWebinar control panel and get those questions in. Next question, I may have missed this in the presentation, but testing is a critical part of the SDLC. Where in your structure is this conducted?
So I'm not sure if the question is relating to security scanning, like testing security related issues, or testing in general. Generally speaking, testing is basically done in the build. So usually in continuous development, there are automated builds, and it can be nightly builds, but also weekly builds. And during these builds, you actually perform automated tests. And that's also where I recommended to put the security tests. So you can scan your code inside just as a post-build step in Jenkins, for example, and that's how you can test and make sure that there are no vulnerabilities. And another important thing here is if something happens, if there is a vulnerability, automatically fail the build. And that's how everyone will know that something is not okay. So what I would recommend is really fail the build, not only alert, but making sure that no vulnerabilities will go to the next stage, which is packaging and production.
Excellent. Okay, great. Next question. Do you offer a vulnerability monitoring service? And what languages do you support?
So I guess the question is about WhiteSource. So WhiteSource supports more than 200 languages. We support all the package managers in the market, of course. So if you're using Go, for example, we have extensive support for Go. We have more than 7 package managers specifically just for Go. So we have, I think, the best coverage in the market in that term. And we, of course, offer security scanning, and we offer monitoring across the lifecycle, along with workflows and reports.
Okay. Excellent. Next question. Do you have some example scanning tools that integrate well with the dev, build, deploy lifecycle?
So not to be specific with any tool, but there are a lot of open source tools, free tools that do the scanning part. So most of them actually integrate to the build lifecycle and to the CI/CD. So the way it usually works is that you will add a post-build step to your build. So right after your build is performed, you will test for vulnerabilities. And usually, for example, our tool is a simple jar. So it's a unified agent where in one jar, in one command actually, we perform the test for all the package managers and all the languages. So you don't even have to be sure which specific languages you have in the build. You just run one command and that's it. You know that you will have all the output that you need.
Okay, great. The next question, we are running Node.js. What are recommended tools for code analysis?
So there are a lot of tools. I know that it's not specific for the language. So usually when you choose a tool, there are a few things that you need to make sure. So the first one is the one that is mentioned in the question, which is the coding languages that you use. So most of the tools support Node, and they also support more languages. So the more limited tools will usually support like 5 languages, and advanced tool will support hundreds of languages, like for example, WhiteSource. So, but the language is just one part that you need to make sure. Some other parts that you need to make sure when you choose the tool that you're going to use is also the ability to integrate with existing CI/CD that you have. The ability for workflow. So, for example, what happens when a vulnerability is detected and how is that handled? The prioritization. So, does the tool have an option to automatically give you a prioritized list of what you need to handle? So there are a lot of aspects really, not to be specific with any tool, but there are also a lot of parameters that you need to think of when you choose which tool you're going to use.
Okay, great. Just a reminder to the audience, if you have a question for Shiri, there's still time if you want to just use the GoToWebinar control panel and submit the question. We have one or two left here. Okay, next question. Which code scanner do you recommend the most?
The questions repeat themselves.
I know, right?
Yeah, it's okay. Again, I don't want to be specific about any code scanner as I'm not familiar with all of them. I didn't test all of them, so I don't want to give a specific recommendation. The recommendation that I can give, of course, is WhiteSource because I work here, and I know it's the best tool. No, just kidding.
Good answer.
But yeah, but as I mentioned, I think that the most important thing is take one open source tool, take one tool, as a paid tool, and try to compare between them. It's also not always a matter. I mean, if you're a company, if you're a small startup, you might not even need something that's being paid for. Maybe you can use a free solution. If you're a larger company that also needs reports, for example, or workflows and stuff like that, you might need, the more advanced solutions in the market, and then you might want to explore a paid tool like WhiteSource, for example.
Okay, great. Next question. Let's see. What vulnerability database do you match against? And does WhiteSource have an internal team that checks open source components for vulnerabilities? And then finally, and how does WhiteSource minimize false positives?
Okay, so these are very good questions. So first of all, in terms of the security databases or security resources that we have, so WhiteSource uses more than 13 databases to scan for vulnerabilities and to match the vulnerabilities against. So the most famous one is the NVD, of course, and then we also have the issue trackers. So there are lots of issue trackers where vulnerabilities are being published every day. And then we also check, for example, for specific GitHub repositories, if there's something that pops up, we automatically alert and add it to our own database. So it's sort of, there are a lot of databases that we collect from, and we make sure that we have the most recent data all the time. Now I think what the second part of the question was?
Does WhiteSource have an internal team that checks open source components for vulnerabilities?
Yeah, so we actually have a research team that's responsible for really understanding all the implications of the open source components and making sure that we are most updated in terms of new data that goes online. As I mentioned, GitHub or Jira or such issue trackers can also have vulnerabilities information. So that's what our research team actually does in order to make sure that we have the most updated information in our own database. And then there was a third
And the
part.
last one, yeah, which is how does a WhiteSource minimize false positives?
Okay, so that's a really good question. So it depends really if we're talking about source code or binaries, as these are very different in when speaking about false positives. So what we actually do is we use the SHA-1, we use a digital signature that identifies the library. So that's how we can actually be sure that if we identify the library in the customer's code, in the code that the customer scanned, this is actually the actual library that the vulnerability was published on. And that's one of the most important things. So in terms of data, we also need to be updated in terms of which libraries there are in open source in general and which vulnerabilities are there. And that's how we make sure to have as minimal amount of false positives as we have.
Okay, great. The next question, do code scanners only scan for known vulnerabilities, or can they detect them during developing?
Okay, so that's actually a very good question. So what you can actually do is there are a lot of kinds of scanners. So we currently discuss the open source vulnerabilities, but there are also scanners for non-open source vulnerabilities. And what there are tools that also check on the runtime level. So as the code is executed, what are actually the vulnerabilities that are currently effective. And this is maybe a good point to mention effective usage analysis, which is one of the technologies that we use for prioritizing the vulnerability. So what it actually does is it checks for the actual source code, the proprietary code of the customer, and then we check and we see if there is any specific method that's called to the open source. And instead of showing all the vulnerabilities in the open source, we only show the effective ones, the ones that were actually called by the proprietary code. So this means that if you have, for example, a library like Angular, it can contain hundreds or thousands of vulnerabilities, but only a small part of them is actually effective in terms of your own code. And that's a technology that we developed and that we use to make sure that the prioritization is done in the right way.
Okay, great. So there's a question here that I'm going to read it as it is. It's a little difficult for me to decipher, but perhaps, Shiri, you understand exactly what they're asking. We are using Bugzilla like ticket raising tools. If I face any security vulnerabilities in that, how could I fix that?
Okay, so Bugzilla is like sort of one of the issue trackers that I just mentioned. So it can be Jira, but it can also be Bugzilla. So in Bugzilla, for example, we see a lot of security vulnerabilities, and if you see one, it's very important to patch it. So usually in platforms like WhiteSource or other platforms, along with the actual vulnerability, you will also have the suggested fix. And the suggested fix is what you need to change in order to be secure. So usually it will be something like, in order to remediate this specific vulnerability, you have to upgrade this and that version, or you have to change something in your properties. And that's how you can sort of fix the vulnerabilities. So I hope this answered the question.
Okay, great. Let's see. Looks like we have one more question. Guys, if you have a question for Shiri, we'll make this last call for questions. So if you have any, go ahead and get them in, and we'll tackle this next one. I may have missed this early in the presentation, but do you see a large number of customers integrating SecOps into the build deploy chain? I think everyone agrees it should be done, but additional testing on each build can be a hard sell. with some customers choosing the traditional and more expensive security test at the end of development, or just relying on the infrastructure as a service provider's tools to protect the asset in production.
Yeah, so we actually think that DevSecOps is really a key to succeeding in, monitoring the security. And also it's a great challenge. We see it with almost all of our customers where you have a security person that doesn't really speak to the developers on a daily basis. And then when the security person comes up with this new tool that the developers have to start using right now, they don't really like it, and there is a lot of friction between security and developers. And that's why we think DevSecOps is really a great way to, to manage that and to make sure that you have a lot less friction and that you can also start to test for vulnerabilities as early as you can in the pipeline. So yeah, I think it's super important.
Okay, all right. Well, that was our last question. Oh, actually, sorry, got one late entrance here. What best practices would you recommend in transitioning security into the build chain if it isn't there today? Are there steps like focus on this item first, then add this next thing as you gain maturity as an organization?
Yeah, so I think all of it is actually a matter of maturity of your organization. So what I would recommend as really a first step is make sure that your organization is aware of this challenge and that the organization and the leaders and the management know that this is a very big challenge and something that you need to handle. The next thing that I would do is sort of start, even if we say shift left is a big challenge. So I would start maybe with the build step or with the image registry and just show that in one scan you get a lot of vulnerabilities. That's how you can sort of make the organization aware of this fact that you have a lot of vulnerabilities. And then as the maturity of the organization grows and they shift to continuous development, this would be the best step to really put the security inside that continuous development and make sure that you scan on every build and that you do the research as you should. But this is, yeah, it's definitely a matter of the maturity of the organization.
Okay, all right, great. Well, that is the last question that we have. So I do want to thank everybody who did submit questions. We had a lot of great ones, so appreciate the interaction there. Just want to remind the audience that today's event has been recorded, so if you missed any or all of the presentation, you will be able to listen to it again. We are going to be sending out an email post-event that will include a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always check it out there. Just go into the webinars tab under on demand, and it should be there waiting for you. And obviously, while you're there, take a look at some of the other webinars that we have both upcoming and on demand. Hopefully, there'll be one or two that pique your interest. Shiri, thank you so much for a great presentation. I know the audience got a lot out of it, judging from the number of questions. Thank you so much. Yeah. Great, and also thank you to the audience for joining me today. And this is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.